How would you graph it?
Yeah, how do you solve it first? How do we solve it? You just said it. Negative 102 to each side. Yep, add a negative 102 to each side or subtract 102 from each side, because that makes this 0 and this is x. So now we're at 448, yes? Okay, so how do you graph it? Well, make a number line. Give the title of the number line graph the variable x. And this is the end point, because we need to graph every single number that's less than this. So we might just put a mark out here and say there's the end. Somewhere back here is 0. These are negative numbers. And then when we begin graphing, this is open because it's not included. So this goes back to a lesson from chapter 3, the initial graphing of this. And then we shade everything back, including the arrow. That's your graph.
And shading represents what again?
I'm sorry?
And shading represents what again?
Everything that's less than 448 is what we're shading. Because everything that's less than 448 could be a number that we put in here. So for example, 0 is less than 448. The number 10, these are all numbers that could be a solution. So it's more than one solution. So the graphing. The graphing comes from lesson 2, or lesson 8 from chapter 2. Yes?
Check the page of answers for the graphs that you get looked at, it has like 2 arrows.
They had 2. So an arrow like this?
No, on the end that was shaded, there was 2 arrows.
Down here there was 2 arrows?
Yeah.
Really? Let me look in the back and see what they did. Like on page S15.
Yeah.
So lesson 5-6, S15, 2 arrows. Oh, I see what you're looking at. On the bottom of page S15.
Yeah.
I see what they did. So what they're doing is they're graphing f is less than negative 13. So if that's what they're doing, they're graphing f is less than negative 13. Here's what they did. It's sort of like this, where the original number line that I drew had an arrow, and they got down to this section and they said, okay, there's the arrow, this is the arrow of the shading. So they had a big arrow for the shading, and then this is all shaded in. That's what the book looks like. Yeah. I think that means it keeps going as well. This is weird. I'll be honest, I can't remember ever seeing this before, but that doesn't mean it's not in there somewhere. So if you want to do it this way, that's fine. I just have always taught shading over the arrow rather than making 2 arrows out of it. It means the same thing. It continues on. So no matter how small of a number it is still less than 448. This would go forever and ever. that okay then? Okay. Question? Just scratching, okay. You wanna see another one?
Yeah.
Which one?
Any of the ones like, what was that,
Ariel, say one more time.
12.
12, okay. The plastic's starting to get in the way. So 12 is negative 44 plus t is greater than or equal to 3. Is it negative 3, did I say? Positive. Okay. So treat this as though it's equal to come up with your solution. So what would you do to get t alone?
Plus, yeah.
Yeah, you add 44 because that cancels out and makes 0. But both sides have to have 44 added. So that's 47, yes? Okay, so now we have to graph that. So what would be numbers that would work? So, think back on your test. What are possible solutions for t? Numbers that can fit in here and make the statement true. 47, because it's equal. What else?
0. Wait, no, my bad. 48.
48.
I said
50.
60.
60, and so on, right? You're not going to have 35 up there, are you?
No.
Or 0,
Yeah.
or negative 5. So all these numbers have to be bigger than or equal to 47. So 47 is like the cutoff. So that is what we call an end point, and we need to graph from that end point, because this is where the numbers begin. Does 46 work? 46.99999999999. No. So if 47 works, it's closed. Put 0 up there so we know which direction we're looking. We go to the right, right. We shave to the right. All the way. And then call it T. So this might be a little confusing. And let me take you back to this. Is this confusing? No, it's not. So just do this. There you are. That's what it is.
You just got rid of 2.
Yeah, just get rid of the vertical. We don't need a vertical axis here because there's only one variable. If you wanted, that's where the vertical axis might go. But it doesn't need to be there because we're not talking about 2 variables, we're only talking about 1. Someday we will put this all on 2 axes. Not this week.
Oh, they're going to say 3.
We have other things to accomplish first, but it's coming. Eventually you're going to.
3?
Yes, if you go that far in your math, 3, and imaginarily 4.
But there's no 4.
Yeah, there is. We're just not ready for it yet, okay? I'll never teach you anything like that. But some of you may go that far, to study dimensions beyond 3. I hope you do. Should we do another one? Okay, which one? How about 9? How about if we do one that's a word problem? Because there you got to write the inequality, you got to put it in words for your solution, and then you got to graph it. So at McMurdo Station in Antarctica, the high temperature was negative 12 Fahrenheit during the day. The nighttime temperature fell to lower than negative 25. But they don't tell us how low, right? Just lower than. If you want to move over so you can see better, you can, okay? By how much did the temperature change? Hey, that's a tough one, isn't it? I think a picture is in order. So some of these problems, sometimes it's easiest to start with a graph and then figure everything else out. So here's a thermometer. We're going to work below 0 because these are cold temperatures, yes? So where did the temperature start?
-12.
-12. So this is degrees Fahrenheit. There's the title of my graph. So it started at -12. Did -12 happen? Or was it just colder than -12? What's it say? It was -12. So then if I graph it, is it open or closed? Closed. Okay, so how cold, it got down, so down in temperature, so how cold did it get?
Below -25.
So it went below -25. Did they say where it stopped? No. I'm sure it stopped somewhere. But it could have been, ooh, not here, right? It got below -25. So what's the question? By how much did the temperature change? Ooh. Okay, so now the temperature did something like this. So the temperature got not 25 below, but it got colder. So it got all these temperatures down here somewhere. So if it started here and it ended somewhere along here, how much did it change?
Below,
More than 13. If it changed exactly 13, that means it could have been -25, but they said it was colder than -25. So the change is more than 13 degrees Fahrenheit. So there's your words. More than -13 Fahrenheit, or was more than 13 degrees Fahrenheit colder. You could say that. So now we need to graph the change. So the change has got to be a number that's more than -13. This is where it gets kind of weird. Because I could write this two different ways. This section right here, I could say more than 13 degrees Fahrenheit colder. So it could have been 14 degrees colder, 15 degrees colder, so on, right? And depending upon how you word this, you can graph it two different ways. If you graphed it by the number of degrees change, you could graph it positive. So that shows more than 13 degrees of change. Which I think the purple one is easier. This one, if it's more than -13, then it could have been -15, or -20, or -30 change. So then you would have to go this direction. So that one can go both directions depending upon how you word it. Because -13 is the opposite of 13. So the black one is kind of like if you added negative numbers to go down. And the purple one would be like if you subtracted positive numbers to get colder. So if that one's fuzzy, don't live or die on that one. That's a hard one. The 11 through 16, those kinds of problems, you ought to be able to do. How about 18 or 19? What? You started asking something?
You only put 12 to 15 together.
Yeah, I may not have assigned 16, but it's the same type of problem. Those types of problems where they simply give us an inequality to solve. Those are what we want to certainly be able to do. Can you do 18 or 19? There we go. How about 18? Since you can check 19.
Wouldn't it be like v plus -13 and then you like add 13 to each one?
So Phoenix says this. Yes? Put those two together to make them -13. And then he said to add 13. So -13 plus 13? 0? So name one number which is a solution.
250.
250. So 250's out here, so this is where we're shading. Is this going to be open or closed circle? Open. Open because it's not or equal to. When it's or equal to, it's closed.
Let me know which end of the underline for the dash, to put the variable. Is it always going to be on the right side?
The V?
Yeah, that one is because it's greater than.
I just put the V on the right-hand side all the time. So like this one here, I would put F and F. I just put it on the right. You know, when we do this, we graph X and Y, we put X over there, right? We put Y up on the top. So I just put my Fahrenheit on the top instead of on the bottom.
So it matter which end you put the variable on?
Is it which direction you shade?
No.
No.
Which side you put the variable on?
Of the graph.
Yeah, does it matter if you put that V on the other side?
No, this is just more customary.
Okay.
It's like, you know, consistency in reading, that's all.
So if you start shading backwards, then you would put the variable on the left hand side.
No, we'd still put it on the right. It's customary to be on the right-hand side, that's all. Not that it's wrong, it's just traditionally put there. It's all about tradition, Hayden. Tradition. So should we leave this and come back to it another day? I say yeah. What time are we out of this honestly? Is it 40? 40, 50. Good, 12 minutes. Conquer the world in 12 minutes. Okay, so here's what I'm going to say. This weekend, for those of you that need to clean up that homework assignment, clean it up. I'm going to look at it on Monday. I'm hoping to be able to see graphs. If you need help with those, there's a lady over here who's around after school every night, and I'm down here every night. I will be here. But clean up your homework if you need to. I'll look at it on Monday. But moving forward, 5-7. What's that?
How much meat production did America?
Meat production in America? I don't know, it's pretty high. Is that in the book? How much meat production is there in the United States? I'm sure more than any other country.
Ah,
I'm certain of that. Okay, so,
China consumes the most dogs.
understanding x plus y is equal to k. Yeah, just looking at it, it's probably pretty foreign to you, although you've seen problems like this. It's just written in variable form. And they begin with the idea that we can consider a circle. How many degrees are in a whole circle?
360.
360.
Actually, infinite.
And if we take part of that circle, and we measure down to this point right here, how far would that be? 90 because of the box in the corner. So that's 90. Is it positive or is it negative? Positive. It's a positive 90 degrees. Now, we could divide that up into two pieces, right? We could take two angles and we could put them together and make them 90 degrees. Those are called what kind of angles when they add to 90? Complementary. Supplementary are 180. 90 are complementary. So let's do this. Let's put together a table of numbers that add up to 90. 10 and? Makes 30. 80. It's another possible pair. 45 and 45. Another one.
89 and 1.
What did you say? 89 and 1. Okay. Could I say 90 and 0? 0 is a zero angle though. Yeah, we haven't really learned about zero angles, they exist, but let's just leave it with like 89 and 1 or 89 and a half and a half. You know, you can put all these together. So there's lots of combinations, right? Quite a few? Yeah? Okay, take out your graphing calculator. Clear out a couple of lists, like number 1 and number 2. Yeah,
I don't know what
we're supposed to have them, right?
I looked at my text.
Well, so now I'm at 1, 2, 3 of you don't have it.
what's in my backpack.
4 of you.
Actually, make that
5. 5 of you don't have it. You know, with that, I'm sorry, I don't have 5 of them sitting here.
That's okay.
Yeah, it's in my
This is
locker.
what happens when I bring mine, everybody forgets
I have
theirs.
2. I had like 30 of them in the other room, but I guess I figure you're gonna be bringing them.
It's in my locker.
I know it's in your locker, but by the time you get back, I'm gonna be sending you back. So you're gonna have to, those of you that didn't bring one, you're gonna have to kind of take note of what we are doing here. All right, so go to list 1 and list 2. How do you get there? Stat, edit. And get to L1. So do this, make L1 and L2 some X and Y values. Remember how to clear those lists real fast?
Yep.
Highlight the L1 and the L2, hit clear and enter. Yes?
I don't have my L1 and L2, I just have L2.
Use your left arrow and see if you can move over and get them.
It just moves there. Got it.
So you lost L1 and L2.
Yeah, it's really weird.
Okay, there's a really fast way to get it back. You do stat, scroll down to setup editor. Hit enter, and hit enter again, and it'll say done. Now hit stat, edit, and they're back. Yep. Okay, so put those 3 in and pick 3 more. Come up with 3 yourself, so that you have 6 of them in your graphing calculator.
How do you highlight all this stuff in there?
Use the arrows to move up.
Yeah, but how do you highlight it?
What's that?
How do you highlight it to leave the stuff in there?
You move the arrow up until L1 or L2 is highlighted, and then you hit clear.
Yeah.
And enter. How are we doing now? Are we there? You have 6 of them in there now? Okay. So let's do this now. Let's graph them. So what I'm gonna do with this is I'm gonna have to set my window so it's not a big, huge mess. The first thing you wanna do is go to Window, and let's ask ourselves, will we ever have any negative numbers?
Yes.
You can have, well, I guess if you went back this way and then you would add something to come all the way to 90, but then we are not gonna be graphing complementary pairs. So let's just talk complementary pairs. These are all gonna be positives.
Yeah, let me go figure.
So I would say make your x go from 0 to, what would be the biggest value that we'd have?
90.
We might have 90, or just less than 90. So run your x's from 0 to 90. Maybe your scale is 10. Scale's not too important, okay? And then run your y's from 0 to 90. That's done in Window.
What's the XRES?
Well, that's beyond our pay grade right now. I'm not gonna, you don't learn that for another 4 years. Go to Window. Top, yep. And then make your window minimum and maximums 0 and 90. We all good? Help one another? Yes? Oh, so you already graphed it. Yeah, if you graph it and you've got a line, you're gonna have to go into y equals and clear that equation.
So we don't want one?
No, you don't want your line from another equation right now. We're gonna start clean and clear. Okay, so in order to graph it though, you have to make sure that the stat plot number 1 is on. So you do second stat plot, which is second y equals. And you need to turn on plot 1 and you need to make sure it lists L1 and L2.
What do you think it's a look
Not,
Yeah, so you do second stat plot, And scroll down and turn on number 1. No, I'm sorry, you're on there. You hit enter yet? Now move over, hit enter again. And move it over so on is highlighted. Then hit enter. And now hit grab. All right, you got it. Where's L1 and L2? You do second stat. Second and have it. Ah. Can I see you real fast? Oh, that's gotta go 0 to 90. Change it, and then graph it, then you'll be golden. You see your points? Are you graphing and seeing your points?
it says error.
Okay, then we have an error.
You don't plot 1 and 2 on?
Yeah, you need one, you need one on, and it needs to be pulled from L1. 0 to 90, 10, 0 to 90.
And then you press graph after that?
Yeah. to that, it's trying to graph that too, now I have graphed it. Yeah, if go to your, no, if go to your y equals and get rid of that line. Not y equals, just y equals, clear that. Now graph, then you're gonna be better. How are we doing now? Okay, so when you look at those points and they graph, what does it appear to be?
Dots.
Dots. What's the shape?
A rectangle.
Well, the dots are squares or stars. But what's the orientation of the dots relative to one another? A line. They all appear to be a line. So in this case here, what we have is we have a relationship where these two numbers are equal to 90. So we have x plus y is equal to 90. That's what you have data points for. So for example, if I gave you this equation, which is sort of what I did, but I gave it to you in words, and I said, come up with ordered pairs to graph, that's what you would have. Do not delete those out of your lists.
We won't.
Come back on Monday and we'll finish it all. Are they in a straight line? Rolling.
Yeah.
Just leave it on there and you don't have to do any saving, just don't delete them. We'll finish on Monday.
So our homework is to redo the homework.
Yes, your homework is to clean up your homework from the previous lesson.